everyone. In this video, in this third video, we will learn about uh, order of reactions and half-life. You can see only two subtopics that we will learn in this video because this is a quite large subtopics, and uh, needs more time to explain about this. Okay, so let's start to learn about order and half-life. Okay, you already know that the rate equation shows about the relationship between the rate constant with the concentrations of reactants to the power of their order. Okay, so what is X and Y? X and Y called as order of reaction. Yeah, order for this particular reactant. X is for A and Y is for B. Okay, so what is the definitions of order? It is the power to which the concentrations of the reactant is raised in the rate equation. So once again, order of reaction is the power to which the concentrations of reactant is raised in the rate equation. Okay, so let's see this practice question. For each of the reactions A to E in the question 4, state the order to each reactant. Okay, so once again, the order for each reactant and overall order. I will show you the question. Okay, this is the question. So, what's the order for cyclopropane here? Okay, the rate is proportional to the concentrations of cyclopropane, so first order. And for B, second order. For C, there are two reactants here, which is sucrose and ACE plus. So first order for each reactant, yeah, first order for each reactant. So first order for sucrose and first order for H plus, but for the overall order is 2 because 1 with 1, 2. Okay, how about D? Okay, the rate is proportional to the concentration of AgCl2 and the square of the concentration of K2C2O4. So the order for mercury chloride is 1, and for the potassium oxalate is 2, yeah, because square. So the overall order is 3. Okay, the last is E. So the order for the propanol is 1. Okay, for I2 is 0 because has no effect to the rate, and for X plus is 1. So the overall order is 1 plus 1. This is 2. So this is how we decide the order of reaction and the overall order. Okay, now we'd like to see about how to identify the order of reaction. There are 3 ways to calculate the order of reactions. So this is same as the how we calculate the number of ways we calculate the rate constant. There are 3 ways as well to calculate the order of reaction. First is from the experimental data. Okay, from the rate of reactions and the rate constant. And then the second is by graphically method. Plot a graph of concentration against time and plot or you can use the plot of graph reactions rate against the concentration. And then the third, by using the successive half-life from graph of concentration against time. So please read once again. Okay, so let's learn of how to decide the order of reactions from the experimental data. Okay, through this experimental data, we can see how the concentration of reactants change and how this change affect the rate of reactions. So, for example, look here. If changing the concentrations of A has no effect on the rate, the reactions must be zero order. If change in the concentrations of A produced directly proportional to the rate of reactions, the reactions must be first order. Okay. In other words, in the first order reactions, doubling the concentration leads to doubling the rate. So once again, this is directly proportional. So if you are doubling this, the rate will be doubling. If you tripling this, the rate will be tripling as well. Directly proportional for the first order. If changes the concentrations of A lead to the square, the change in the rate of reactions, then the reactions must be second order. For example, doubling A, four-fold increase in the rate of reactions. Tripling A, nine-fold increase in the rate. So in this syllabus, we will learn about zero order, first order, and then the second order. Okay, I just told you that there are three ways to calculate the order of reaction. First is by the experimental data. Okay, now we have this table, and we should use this table to work out the order of reaction with respect to reactants A and B, and write the right expressions for this reaction. So for example, we have the reactions A plus B becomes product. Okay, we want to find out the order for each reactant. Okay, to answer this question, we should see this experimental data. To calculate the order of A, you should find experimental data where concentration of B is constant. So once again, if you want to find order of A, you should find experimental data where B has constant concentration. So you can choose experiment 1 and 2, okay, because same, or experimental 1 and 3, or experimental 2 and 3. Okay, you can choose, yeah, because this is same. Okay, so for example, I'd like to use experimental data 1 and 2. Okay, once again, rate equation equals to K times concentration A to the power of A, for example, times concentration of B equals to the power of B. We want to compare experiment 1 and 2. Okay, so I'd like to make this rate 1, K times concentration A in experiment 1, times concentration B in experiment 1. And then I will compare with rate 2. So K times experiment A in experiment, the second experiment, times B at the second experiment. Okay, you can see that the value of K will be constant, yeah, in experiment 1 or experiment 2, because we will keep the temperature constant during this reaction. We just change the concentration, so we can cancel this. Okay, then we'd like to fill with this value. Look, experiment 1 here, and this. Okay, 2 times 10 to the power of -4 over 4 times 10 to the power of negative 4 equals to concentration A at experiment 1, which is this 0.1 to the power of A, okay, times 0.1 to the power of B over 0.2 to the power of A times 0.1 to the power of B. So you can see once again that B can be cancelled out. Yeah. So that's why we should find with experiment data where the concentration of B constant, because we want the ratio is 1. So the focus is just from the concentrations of A. So let's solve this problem. So 2 over 4 is half, okay, equals to, we can combine this 0.1 over 0.2 is half again, and to the power of A, right? So this should be half to the power of 1, so 1 equals to A. A equals to 1. So the order of A is 1. The first order. Okay, now let's see how we calculate the order for B. Okay, to find the order of B, we should find the experimental data where A constant, which is 3 with 4 or 3 with 5 or 4 with 5, right? So let's say I like to choose 3 and 4 data. Yeah, 3 and 4 data. Use experiment 3 and 4. Okay, so red at experiment 3 equals to K times A at experiment 3, the power of A, B at the third experiment to the power of B, over red at experiment 4. So like this. Okay, once again, you can cancel the value of K. And since A will be same as well, 0.3 over 0.3, so you can cancel this as well. Okay. So right, 3 is 6 times 10 to the power of negative 4 over equals to B. This is 0.1 over 0.2 to the power of B, right? Like this. Okay, now we can use the calculator. So this is 60 times 10 to the power of negative 3. Wait. No, 0.6, yeah. 0.6 to the power of negative 3, right? Over 2.4 times 10 to the power of negative 3 equals to half to the power of B. Okay, once again, we can cancel this with this. Okay, and this is 1 over 4 equals to half to the power of B. 1 over 4, that means half to the power of 2 equals to half to the power of B. So B equals to 2. So order of B would be 2, the second order for B. Okay, after we find the order for each reactant, we need to answer the red expression. We need to write the red expression for this reaction. So the red will be equals as K times concentration A to the power of 1 times concentration of B to the power of 2. So this is the red expression for this reaction. Okay. So once again, this is the way of how to find the order of reaction by using the experimental data, the red and the initial concentrations. So this is a summary. If you change the concentrations of reactants and it will not affect at all to the rate of reactions, it is a zero order. But if you change it double and the rate will be double, it is a first order, directly proportional. But if you double the concentration and then the rate